Hello everyone, welcome to our presentation. Today we are going to make a dataset exploratory data analysis according to our dataset. I would like to introduce my team members, Umay and Bilge, and my name is Bayram Alican. First of all, I would like to give some brief information about our dataset. Our dataset is named as Lending Club Loan Data, and our dataset contains about information of economic profile and history of economic profile and economic history of people who already took loan from Lending Club, and also dataset contains data about loan status, which is classified as binary. One class is fully paid and the other one is charged off. Charged off means that customer could not pay their loan. He or she bankrupt in that way. Okay, sorry. In the aim of, I would like to give some information about our aim of this project. The purpose of this project is preparing a machine learning model that predicts could customer pay the loan back or not before giving the loan to the customer. The motivation behind this aim is coming from a scenario which is Lending Club desires a machine learning model from us that will be used for new customers who come to apply for a loan. Before giving them a loan, company would like to see that would customer fully pay that loan or bankrupt while paying loan.
Bayram.
Yes, sir.
Can you go one slide back?
Yes, sir.
Okay. That's a good beginning. I would like to thank your team. So what I am suggesting for every teams that now available on the online meeting. So that's what I am really expecting in the first couple of slides. Thank you for that, Bayram. First of all, you need to clarify where you found this data set, as in showed here. And the next slide, please. And please clearly explain what's your aim, in which scenario you can use this machine learning model at the end. So I really like that you approach this problem in these two slides like that. Because if you remember that the documentation that I shared, right, includes this information. It requests this information from you, right, Bayram?
Yes, sir.
So thank you for preparation like that. And the previous team must read that documentation as well. Okay, please continue. It's a good start. Thank you.
Thank you, sir. And according to prediction of our machine learning model, company will decide the approval status of the loan, actually. So why the topic is important in our case? There are two cases, actually. There are many people try to take loan from bank without planning their economic financial profile. So this model will predict the loan payback status, so and that will useful for preventing bankruptcy for people. And also, bank could use this model to separate the loan customer profile better. We thought like that. In the general information of the data set, we used orange data info command, and we saw that there are nearly 396K of samples, and there are 24 features, but one of them will be a target, so there are total 23 features at now. Also, there are three metadata as shown. The our aimed target will be the loan status, as I mentioned, and it's a binary class target, which is fully paid or charged off.
Okay, Bayram, can you go
Yes.
back again? So that's what I am expecting you, beginning with the very top view of the data set and clearly state the target column or target feature here and the other features. So by using the Orange data mining tool or machine learning tool, you can get these basically very simple way. And I like that way. And I suggest you use the Orange in your data mining. I don't expect you to using another Python. If you feel comfortable, you can use Python. But in that course, we are approached this problem by prototyping, fast prototyping. So you can use Orange. It's enough to share this kind of information. Thank you, your team, Bayram.
Thank you, sir. As I mentioned, in the raw data, there are 396K of samples. In the task of the machine learning part, we will work on the supervised model because we will provide target and features to the trained part of the model. Also, I would like to highlight the target from a piece of data set.
Okay, that's what I am looking for. Thank you for that again. In the previous presentation, we are missing such simple information, but you provide the data in a simple manner by using the Orange Windows widgets. I really thank you that you are simply make us understand your problem. That's the good approach, and that's an example for everybody else. Okay, thank you. Please continue.
As I mentioned before, we will use binary class classification with the target of loan status. In the table, which is telling us feature description of the data set, there are many data about the economical profile of the customer who would like to take a loan from lending club. Also, after we saw data in the data info command, we look our data in the data table, and we see some missing data in features and the meta part of the data set. According to these observations, we eliminate those missing data because the missing data percentages are really small according to the whole data. So thanks to Orange, we use a select rows command to eliminate the unknown unknown samples from features. And there are 60K of samples are deleted from our data sets, and from the raw data, we left about 336K of samples. In the next...
this approach is acceptable. As you mentioned that the ratio is very low compared to the, the full samples. So the missing samples are very low. So as you suggested, you can do it. So it's a good implementation of how to handle a missing data. If they are in very low numbers, you can just remove the samples. Thank you.
Thank you, sir. In the next step, we look to the distribution of our target actually to analyze is it balanced or unbalanced. It's definitely unbalanced situation we are dealing with. So we made some actions and manipulations to balance this target. To do that, actually, this is how we balance the data. Firstly, we separated the data as fully paid and charged off in the orange, and we deleted randomly sample from fully paid parts, and at the end we sum them up in the same CSV file and we re-uploaded to the orange, and we saw a good distribution level as shown in the right side. There is a 49% charged off and nearly 51% of fully paid relationship.
Okay, this is one approach. You can handle this imbalance. First of all, it's a good habit always first check the target distribution throughout the labels. You did it well. After noticing that imbalanced data set, there are several options. One of the options is downsizing of the large samples. So you did this downsizing, right? Am I wrong?
Yes, sir. Yes, sir.
Because I think the sample numbers are about 70 Ks right now for each label.
Yes, sir. Yes, sir. It's totally 135K of samples we have.
Okay, thank you. You can continue.
In the next stage, after we clean and balance our data, we go back and look our data info, and we satisfied our job, and we have 135K of samples after manipulations. In the second chapter, we made some analysis according to our eye observations to selecting some useless features, actually. In the data set, there are two grade distribution features. One of them is grade and the other one subgrade, as shown in the slide. As you can understand, subgrade is more wider approach to understand the data set. So we thought that grade could be eliminated because we have already subgraded distribution. So according to our thought and discussion, we eliminate the grade distribution. And after we look to the distribution of subgrade, we examine some lines.
Before moving to this, could you go back?
Yes, sir.
Also, that's a good approach. I tried to explain that in the previous presentation. You are not only showing this some information regarding to some features, but you are comparing these features and you gain some insight and you take some actions. That's what exploratory data analysis is. So I really like the way you do, because it's the thing that you have to do. So you are not only summarizing some statistical information about features, not only this, but you are comparing some features, taking some actions, because you understand your data. It's really good that I really congratulate you that you did it well. Bravo. Continue.
In the grade subgrade distribution, we focused on A1 to A5 distribution, as we saw that there is 80% of samples are fully paid over charged off, which is took our attention. Actually, we could give more attention to this feature. We thought like that. Also, we see same scenario in the F1 to G5 distribution, which is a bad loan grade for the customer. So there is a high level of charged off customer level in that field.
It's
We
really
observe.
good analysis, another good analysis. So you can understand that from these distributions, right? Scatter
Yes, sir.
diagrams. You would understand that you can actually successfully classify these the customers by looking only, for example, to that subgrade feature, right?
Yes,
So
yes, sir.
you have some hope to do
Yes, sir.
this job, right?
Yes, sir.
So it's
We
really
hope.
good you did this. Bravo.
Thank you, sir. In the second feature, issue date is described as application day for taking loan from the company. We thought it's useless because in the real life, interest rates are clearly proportional with the issue day because it's changing by day. But according to Lending Club, it's not changing day by day. It's changing according to financial profile of the customer. So we would like to delete this feature from the dataset. In the next feature, earliest credit line, there is no, it describes the last time that client takes a loan, and there is no any status for the lastly taken loan. So we thought we could not predict according to this timeline, and we proved that with the graph scatter plot in the right side. There's not a good harmony in the look, so we also delete this
Correlation, you mean, right?
correlation. Yes, sir. I'm
Okay.
not
Okay.
in the, thank you. And lastly, I would like to mention about initial list status. This is actually a product type of the loan. F means fraction, V means whole loan. This is a type of Lending Club marketing strategy, but we don't care because the distribution of each class is too much near as shown. For example, in the F class, there is a too similar with the V class. So we thought that we could not predict any type of, we could not predict charge off or fully paid from this feature because of the distribution of classes. According to that, this is what I would like to talk about.
But Bayram, could
Yes,
you
sir.
please go back one slide?
Yes, sir.
Okay, here you notice that at any graph on the screenshots, there is the find informative projections button. Did you notice that?
Yes, sir. Yes, sir.
Did you use this?
Actually, it didn't give us what we desire, sir.
Why? Because it finds, everybody knows that in orange, in that scatter plot diagram, it can find, it can calculate the correlation between the features and the target values, right?
Yes, sir.
So you can use to find the most informative features with that, I believe.
Yes, sir. We
At least, Bayram, at least you decided to remove some features.
Yes,
we
sir.
can double check it that If their correlation is very low, you can double check and you can delete it with save. Do you
Okay,
understand?
sir. Okay, thank you for your
At least
notification,
you
sir.
can try to use it for removing and checking your decision for removing some features if they are really low correlation with respect to target values.
I see, sir. Thank you for your
Okay.
comment. This is what I would like to talk about. Nextly, my friend Bilge will continue about her stage. Thank you.
Hi, my name is Bilge. Today I'm gonna show you some important features by visualizing. As Bayram explained, given historical data on loans given out with information on whether or not the borrower default, charge off. Before starting this way, we tried to answer the following question by looking at the features. Can we build a model that can predict whether or not borrower will pay back their loan? This way, when a new potential customer is received in the future, we can have an idea of whether they will repay the loan. So I will talk about how and with what features we are trying to do this. Let's get into it. Let me show you some features. I mostly use box plots. The box plot widget shows the distribution of attribute values. Before the previous slide, Bayram, you can see here the data is almost balanced after some work. As you all know, the balanced data is good for classification. Next slide, please. Purpose feature in our data set. With this, we can see for what purpose people want a loan in our data set. The purpose feature shows you why they want to get a loan from Lending Club. It is seen that the vast majority are requested for credit cards or for debt consolidation purposes. And next slide, please. The other feature is application type. We have 3 different application types. Although not visible in the screenshot, there are 2 more categories: individual, direct pay, and joint type of application. But in our data set, the percent of direct pay and joint application is very low. 0.007% direct pay and 0.11% joint. Since the content of these 2 classes is too low to be considered appreciable, we intend to ignore this feature when we training our model. We think that this feature is not important enough to affect our targets. Next slide, please. Verification status feature. This verification status feature indicates if income was verified by Lending Club, not verified, or if income source was verified. As you can see, the distribution of these 3 classes are almost balanced. Next slide, please. Loan amount feature. I think the loan amount feature is our important feature. The amount of the loan applied for by the borrower, if at some point in time the credit department reduces the amount, then it will be reflected in this value. I wanted to use box plot to explain this feature. I also selected annotate box to display the end values. If you ask me what is the end values, I would say the mean and the median. The mean, the dark blue vertical line, the thin blue line represents the standard deviation. Yellow vertical line represents the median. The mean value is, average value. The median value is in the middle after use, of course, sort all the values. If the loan amount is higher, we have a slight increase in the likelihood of being charged off. This makes sense. It's often harder to repay larger loans than smaller loans. Since I think this feature is very related to installment, I prepared something for that combines both. And next slide, please.
Before continuing with the next slide, could you go back one more? So Bilge, thank you for explaining all these for everyone. So if you look at this box plot, since it's categorical information in the verification status, we only see the numbers there, the total numbers, right? Verified, not verified, etc. And it shows the distribution of the target value, charged off or fully paid. And under the diagram, you would see that chi-square, you see that there is the chi-square, which is 1,606 blah, blah, and p-value and DOF value. Actually, I didn't teach these things to you. A little bit, they are detailed, but actually they show you the confidence level with respect to these class distributions. And p-value is important. It shows the, can you trust these values? It should be at this 0.005, but it's less than this. So actually, if it's less than this, it means that you cannot use these classification actually. So as you notice that these are all balanced, distributed, charge off and fully paid. Actually, the statistics also tells in numbers. You cannot count on these feature to differentiate between charge off and fully paid. Next slide. As you explain here, thank you for the explanation. It shows the medium, average, and standard deviation to standard deviation to the left, to standard deviation to the right from the average. And there are the other, you see the blue region. Outside of the blue region, there are the purple line to the left and to the line. These are the outliers, right?
Yes.
Yes. So, as Bilge explained, when you use a box plot, you need to understand these two things. First, for the continuous value feature, you will end up with this kind of box plot. But if you are using a discrete feature, as in the first previous slide, you will end up with another box plot, but you need to read both of them. Here you see the student's t value. It gives you some idea about the correlation. And p value again, it shows that if it's a significant, statistically significant or not. Most of the time, if it is less than 0.005, it means that it's not significant. So here you see that actually it's not significant, the amount of loan to decide it's gonna be paid or not.
Yes.
So thank you, Bilge, to explain these graphs. Every team need to use this box plot and understand the relationship with respect to the target value. Thank you. Please continue.
First, I want quickly say what's the installment in our case. Like everybody know, installment is the monthly payment owed by the borrower if the loan originates. We can see that the loan amount has perfect correlation with installment. It makes sense to be highly correlated because the higher loans means the higher installments and vice versa. this relationship, of course, governed by a fixed formula. But you can see the linearity in this plot, the high. And of course, in here, you can see different colors by a loan amount. As teacher said, maybe it's not important to do, but it is very good example to see the loan and installment correlation. And my friend Umay will continue.
Hello everyone, I am Umay Shahan. I will present the feature statistics and feature selection by using logistic regression. In this part, I have used feature statistics in Orange 3 tool to show you this table. As you can see, most of the features are balanced. When interest rate is low, as you can see, loan is generally fully paid, but when interest rates start to rise, people could not pay their debts. When we look at the DTI feature, DTI is debt to income, and that means a ratio calculated using the borrower's total monthly debt payments on the total debt obligations, excluding mortgage and the requested lending club loan divided by the borrower's self-reported monthly income. When this ratio is low, fully paid proportion is lower than charged-off, as you can see. When this ratio is highest, charged-off proportion is higher than fully paid. Next slide, please. When we look at the term feature, there are two types of term, which are 36 months and 60 months. As we can see, when term is 36 months, proportion seems like balanced. However, when term is 60 months, charge-off ratio is bigger than fully paid. Next slide, please. They seems balanced. Next slide, please. After feature statistic part, we would like to...
Umay, before moving to next, please go back. Okay, in any slide, okay, it's okay. But if you go back again, because these are the one more, let's see some continuous values. Okay, now, actually, Umay, I would like to see that you are mentioning about the scales of the features. Look at the min and max values, Umay. Okay, you see that the scales are very different. You see that there are 40,000 for loan amount. But if you look at, for example, DTI is very small compared to this. If you look at to other, for example, which one is that? Revolve ball, right? Revolve ball, it's a very huge number. So you remember that from the classes, linear classifiers are very prone to the scales, right? So if I were you, I would like pay attention to these scales, and I would mention that we are gonna scale, normalize these values for each feature. Am I right?
Actually, in Orange tool, we use pre-process, and we
Okay,
normalize
in the EDA. You need to pay attention for that. Okay.
Okay.
All right. Please continue.
In Orange, we use this. In pre-process, we normalized values 0 and 1 to remove data redundancy. After that, data sampler, and we use logistic regression. We would like to prove our opinions with using logistic regression. Logistic regression is widely used in linear classification problems, although it is called regression. there's a classification here. When we have used logistic regression, we used lasso as a regularization type. At first, we take a C value as 0.190, and then we took these results. As you can see, term 36 months value is 0. This means it is not important for dataset for our prediction. Next slide, please.
Okay, I would like to thank you for that. It's really good idea to use this information where you learn in the class at the EDA. Thank you for that, because not many people use this lasso for feature selection. So it's a good idea to use this and to show that because you are gonna, I believe that you are gonna delete or remove some features, it's a double check for that, right?
Yes.
Okay, thank you. It's a good idea. Bravo.
When we see employment length, there are several 0 features, but there is a feature actually. They are classes. Home ownership have 0 values too. Next slide, please. When we take term 36 months is 0 to. When we take strong C value, when we low value of the parameter of C, actually, the models put more emphasis on finding a coefficient vector that is close to 0. When it is weak, it is 0 too. So we decided to take strong, because when it is weak, there are zeros, all the same zeros. So we decided to take C 0.190. There are proofs. Next slide, please. As you can see, there are zeros. Next slide, please. Thank you.
Thank you for your attention.
I really like the presentation. Thank you for all the team members. It's a good EDA. Okay.
Thank you, sir.
There are several missing points, but for the moment, it is very good. I like it. The way you present the topic is very good, from simple to complex information, and how to handle and how to use the orange in your presentation is really good. I really like your presentation. I want to thank all of you.
Thank you.